very honored to be able to speak here. And it's the first time speaking on a conference dedicated to Micro Frontends. So the great part about this situation is that I can mainly skip what Micro Frontends are and go a little bit deeper in what we actually do with Micro Frontends. And so I'm quite inspired to doing this talk here under these conditions. So let's get started. The talk is titled "How Deep is Your Micro Frontend?" Later on, you will learn what that means. First, a few things about me. So my name is Michael. I'm a software engineer. I do front-end architecture. I really enjoy web technology. Written down web technology fanboy if something like this exists. I've written a book about this topic. I also run the website. When I don't work on Micro Frontends, I also do open source work for making solar charging easier. But this is a topic for another talk. So in my during the week, I work at a company which is called Neuland Büro für Informatik. And we are building e-commerce systems for larger companies. So mostly traditional companies that exist for quite a long time. They have warehouses. They used to send out catalogs, for example. Some of them also sell tractors. We work together with these companies on their e-commerce systems. And we have a common situation across most of our clients where at one point in time they started to outgrow the system they started with. So they started with oftentimes with an off-the-shelf monolithic e-commerce system, and at some point in time they reached a limit. And there are two categories of reasons for reaching this limit. One thing is technical reasons. So scaling the monolith was getting more and more expensive, and also changing stuff in the monolith introduced errors that weren't intended. And on the other side, we have organizational reasons. So having too many people working on one code base, for example. And this is oftentimes countered with, okay, then we add rules and processes to avoid chaos and bring a little bit more order there, but it slows down development, and all of the people in there were unhappy. So the solution we did with many of our clients, and we are quite fond of this solution, and our clients as well, is moving from a monolithic system to a Micro Frontend style system. So we don't use the term Micro Frontends. We always call this verticalization. The term Micro Frontends, when it came up, closely fitted the thing we were doing then. And this is the topic for today. So let's talk about one of these stripes you saw. So I will talk about what the height of this this box means, and how this can vary. And we also talk about the width. So how wide should your Micro Frontend be? And in the middle, in the later part, we'll also do. I have prepared a real-world example from a project. Where we had a challenging situation on how integration should work, I will explain you this challenge we had, and give you something to think about and take away when you're facing a more complex solution on integration. Okay, so let's start with the depths. When we're talking about Micro Frontends, and Micro Frontends has the name Frontend, as part of its name. And oftentimes it's a little bit misleading, because people hear Micro Frontend and they think about, okay, something for the front end, maybe microservices in the front end. And this is not totally wrong, because the techniques we are using when you look for tools, these are mostly tools that operate in the front end. Because in order to do an effective Micro Frontends architecture, you need the decoupling in the front end. This is something new. But I also saw a lot of projects where Micro Frontends is only done in the front end. So you have a classical microservices architecture, an API gateway in between, and then Micro Frontends just in the front end layer, only in the browser. Or having this on top of a monolith, for example. And this is perfectly fine. So this can solve problems. and it's good to have the tools to address the issues and make you faster in that way. But I also sometimes see it one level deeper. So you have the front-end stuff, but also a back-end layer, which is aligned with the front-end. So seeing a back-end for front-end, I've seen a back-end for front-end in many architectures, for example. So you have a front-end system and an associated back-end system, which mostly does orchestration and aggregation of data from an underlying back-end services architecture where the actual business logic lies. And this is also fine because now we have more control. The micro frontends can get more tailored data for them, but we can even go one level deeper. So now we also include the business logic. I don't have good terms for it, so I call it backend 1 for only the backend for frontend and backend 2 for data gathering and the business domain, so including also the business logic. And this is nice because now we have a system, Stripe, where the front-end logic and the back-end logic is all aligned with each other. And I've added a layer below. So in some of our projects, or in all of our projects, we need to think about operations. So we have an application, we need to deploy it somewhere. We need to think about databases. We need to think about PagerDuty, for example. What happens if something goes wrong? Who does debugging? Who gets called? And we can leave this out of the Micro Frontends architecture, but we can also go one level deeper and also integrate it. So we have front end, back end, and also ops. So a DevOps, a DevOps-like team where you have some kind of you build it, you run it mindset and architecture there. Okay, so these are the 4 levels. I've created a little table. On the left side, you see the levels I showed before. And in the top, as the columns, you see different properties or different benefits we get for going, for building a micro frontend architecture of a specific depth. And now I'll go step by step through the columns, explain what I mean with it, and then do a little filling out of this table and rating these properties. The first one is the most obvious one. So when you start dividing your front end, now you gain technology independence. So you can use multiple frameworks side by side. This is one of the arguments that is most often used, but this is, in our cases, this is not the reason why we adopt them. But it's very handy. So even if you decide that all teams start with the same front-end framework, for example, it might be handy at some point in time that a team can decide to maybe try out the next version. So they do an upgrade to the new version of the same framework and do a pilot, for example. And if this team says, okay, everything fine, that works, the other teams can follow in their own speed. This is really valuable, and we've used this property a couple of times. So all depth levels have this because it's just a feature of having the divided front end. And the second one, so being able to parallelize front-end development work. This is also given because now we have different systems, they have narrow scope, and teams can work side by side. So now also everything fine. With the next point, it gets a little bit more interesting. I like ThoughtWorks Micro Frontends definition from the technology radar. Florian showed it in his first talk. And they're mentioning 3 properties. So they talk about features being developed by independent teams. And these features are not only developed, they are also tested and deployed by these teams. So now we are talking about testing, and we're talking also about deployment of a complete feature. And if you hear these terms together, you might think about continuous delivery. And this is definitely a goal that our projects, or many of our projects, we're aiming for. So having a group of people being able to do continuous delivery, so delivering feature by feature on a regular basis without being blocked by others is something really valuable. If you've worked in a team for one time that did continuous delivery, I think most people don't want to go back, because it feels really good to move quickly and being able to do small iterations and small shipments. And in this point, we can argue. So yeah, you can also do continuous delivery in a front-end only micro front-end architecture, so just shipping new front-end versions. But the things you can do there, I guess, are quite limited. So you can ship new button colors, you can rearrange stuff in the UI, which also might be valuable. But the real valuable features, most of them also contain business logic. So if you have a subscription plan, for example, that you want to introduce a new tier that is visible in the front end, it isn't sufficient to just add this option to the front end. You also need the heavy lifting from the back end, the logic, when what happens if you change the plans, for example. And as an extension, if you want a feature needs a new service, for example, you need a document store for implementing a new feature. It's really handy if you also have ops capability inside of your team. So I would give the full stack version even one level up. Okay. And now the last column, I think we saw the slide in the first presentation by Florian as well, so I can be a little bit quicker here. So on the right side, we have a cross-functional team, so a Micro Frontends style setup where you have all people with different skill sets in one team. On the left side, you have different teams that are specialized in a specific service, for example. And the huge benefit is on the right side, you have one team. In most of the features, when your teams are arranged in a good way, a new feature most often only can be implemented by just one team, because it's clear which domain this new feature should fit in. And on the left side, there's in many cases more than one team required to build it. And these teams have to coordinate. So they all have to understand the feature. They have to put this feature to their backlog. They have to prioritize it. They have to talk to each other, how the interfaces should be. And this is a lot of extra work, maybe not with lines of code, but especially when you think about time. So organizing meetings and prioritizing things. This is quite expensive time-wise. Yeah, so needless to say, we are huge fans of cross-functional teams, and wherever we can, we try to empower the teams to be as autonomous and as self-contained as possible. So for the rating, I think the deeper the more skills we have in a team, the more autonomous the team gets, because they're able to make decisions and take responsibility on a broader scale. But this doesn't all. There are also drawbacks that come with a setup where you go with high-depth teams. So running or being part of a cross-functional team isn't always easy. So we have people with different mindsets, with different backgrounds, and sometimes you need to be quite professional to make this work and to be productive in this environment. It's also having a full-stack team. So it's your team is able to do a lot of different things, but are not specialists in one specific technology. So if you, on the other hand, would have a dedicated platform team that can specialize in how Kubernetes works, for example, they will be able to build up much more Kubernetes specialism than this cross-functional team would do. And this is fine from a business perspective. I guess it's also valuable to have teams that are aligned across domains and not specialists in specific technologies. But this is something you have to think about, and all members of the team have to be on board with it. And with this high bandwidth of responsibility, this is also something that a team can be overwhelmed with. So this is not easy to be responsible for a lot of stuff. It's much more easy to be only responsible for the things that happen in the browser, for example. And as a consequence of this, you need a greater minimum team size. So running a full stack team with 2 people, I guess, you can do it if you have 2 rock stars, whatever. But this is not how development works in practice, and not in a sustainable fashion. So usually you have teams that are at minimum 4 or up people to make this happen. Okay, so I've added another column here and another row below, but we will fill this out at the end of the presentation. And now I will want to skip to not talking about depth, but more talking about width, and we will revisit this chart here. Okay, so width or varying the width is quite an interesting topic and something we came across in our projects over the last 10 or more years, quite some time. And to explain where we're coming from and what we are talking about, I've added 2 slides here. You can also find them in the book. The one is how we separate our teams, and since we are building an e-commerce system, in many cases, the team cuts are alongside with the customer journey. So you have the homepage and the listing page is done by one team or owned by one team. And you have the checkout process, multiple pages. This is the responsibility of the checkout team, for example. So quite straightforward. But we also have pages where it's required to have interactions from multiple teams with multiple micro frontends on one page. We try to not overdo this pattern, but in some cases it's needed, and then we do UI composition, so having multiple micro frontends on one screen. Okay, so when we are doing a project, how do we start? So usually our usual setup is we have different teams, and these different teams build different systems, and we usually start with a one-to-one relationship. So we have one team that develops one system. And so what is one system? A system represents one domain. It could be a larger one like the checkout process, or smaller one like the product detail page, for example, or everything in between there. And the internals of this system are not really relevant to the others. So a system can contain a front-end and a back-end component, or maybe may consist of microservices underneath. And these inside of the domain, they can also be coupled so that the front-end only talks to this back-end and doesn't have a documented generic interface, for example, because it's not relevant to others. But between the systems, we try to do as loose of a coupling as possible to ensure that these systems can be deployed individually, for example. Okay, so now let's talk about growing and about shrinking. So growing happens if you've started with a system and the feature demand of the system is very high because maybe it's successful, or maybe you have want to try out a lot of stuff and your backlog is bigger than your team can handle, and so the system should grow, and you need a pattern where you are able to cope with this workload. And the other extreme would be that maybe initially there was a lot of work to be done, but over time the system matured and the change rate required gets lower and lower, or the focus of the company shifts and the system is fine, but there's not a lot of extra work to do. So we have both cases, and let's start with the right one. So with the shrinking case. So what to do when this one-to-one relation doesn't fit because the work required in one system isn't needed. Obvious solution could be, okay, then you have one team that's responsible for multiple systems, and this could work perfectly fine. So especially when you have systems that are related from a business domain. So having maybe the checkout team also doing the my account system. If they were designed in two systems and both systems don't have high complexity, then it might be feasible to have one team do both of these systems. And they can also go one step further. So maybe between these systems, there's a high level of complexity with integration and so on, and they're using the same tech stack. It could also be valuable to combine these systems. So maybe you cut a system very, very small, or have two very small cut systems, and you notice that if you would merge these two systems to be one deployable unit, for example, it would solve a lot of issues. I would solve a lot of overhead between these things. So this is also possible. Okay, now let's talk about growing. So we've implemented two strategies so far, not when we had growing pains, but in preparation of being able to grow. So as I said before, we are in e-commerce. We usually know our domain very well. Not all e-commerce systems are the same, but you have a broad, you have some amount of commonality, and sometimes we start not with a one-to-one relationship, but we have one team building 2 of these systems, for example, because they know now the feature load is not very high, but when we are successful, when the demand grows, we are able to split the teams. So then we have one team working on system A and one team working on system B, and then we are prepared and don't have to do anything technical and just split the teams. And this is fine if you are quite sure that you are in a growing scenario. So if you prepare and you have a lot of small systems prepared and don't ever need this flexibility, you're just running with an extra amount of overhead. So having integrations between all of these systems, front-end integrations, for example, that might be easy, but it could also be a little bit more complicated. So you have to be cautious there. And the second pattern is a little bit of an extension, or a little bit more, or a little bit softer version of the thing I talked about before. So you have you start with a one-to-one relationship again, so one team building one system, but the system may be built in a way so that it's easy to take it apart later. So this team builds a modular monolith, for example, or the word modulus came up in the last years. We did this in, I guess, at least 2 projects where we were aware of the system that should be broken apart to a later point. And we called it, there's a nice German word, which I couldn't find a good English translation for it, which we call Sollbruchstelle. So it's an intentional breaking point, which you find in mechanical engineering, or when you're thinking about a piece of paper with a perforation in it, it's one piece, but when you tear the perforation, now you suddenly have 2, and you have 2 individual pieces of paper. So you can think about this. I think this perforation thing is a good metaphor. And I also remembered something like this. So in my childhood, I'm not quite sure if this is if they make it today anymore. You could buy as a child an ice cream which had 2 sticks, and in the middle it was a little bit thinner. So when a friend came over, you can break it apart, and then both of you had an ice cream. When you were alone, you can eat the complete thing. So a little bit similar, but I thought it was a funny idea. Okay, and the most often part for growing is some kind of natural growth scenario. So if you have a team and you notice the team is getting larger and larger, and the system the team builds also is getting larger and larger, it might be wise to watch out for maybe subsystems in this the larger systems that emerge by themselves. So when you have a big search system, maybe you have a couple of people that always work on the catalog, for example. So having the categories and everything that goes with the categories, and maybe it's wise to take the sub feature and promote it to a new system, and also the people that know most about it also form as a starting point for forming a new system. Okay, so now we've talked about growth and shrinking and so on. And I want to stress and highlight a point which I mentioned earlier as well, that when you do fine cut systems, when you have a lot of small systems, then you also, in consequence, it depends on your application, but in our cases, it's often the case, when you have a lot of systems, you also have a lot of integration points between these different systems. And more integration points can also mean more complexity. So we are really careful of doing premature slicing of these systems, and in general try to run with bigger systems as far as we can get away with it. And now I'll show a practical example to highlight some issues you could face when you go to fine grain. Okay, so 2 years ago, I guess, we started working on a customer service back office application. The setup was the customers could have a chat interface on the website, and they could say, okay, I have a project, I need help. can you please support me? And then they can initiate a chat with a technical expert who can write with the customer and give tips and help him. So what we were building was the customer back office, so the experts facing browser application. So they see incoming messages, and we're also able to respond to these messages. This was built in a separate system, everything fine. Then at some point, we are in the e-commerce landscape. There was the requirement that along with written text, you should also be able to include lists of products. So if someone wants to build a chat, maybe there's a prepared list of materials you can use to build a chat, and maybe also tools you would like to use. And this was quite a complex feature because we had prepared lists and you could add products or change something, change dimensions. We also had to think about individual pricing and discounts and availability. This is quite complex, far more complex than just being able to write a text. And so this one was designed as a separate system. And in this chat form, the selection of the materials, so selecting a group of materials, was implemented. Next thing, as an HTML form field. So we did the red team presented or built the micro frontend in a web component. The other team just included the web component, and from the green team's perspective, the web component just acted as an HTML field in it had an ID or it didn't have an ID, and then we have had backend feeds where systems could look up what in a product list ID meant, for example. So the green team didn't have to know anything about products and anything else, and the red team didn't have to know anything about chatting functionality. They just implemented the picker here. And we've used this pattern in multiple applications. So I call it the data picker pattern. So just similar to a date picker, where you don't know the intricate details of calendar and time stuff in all countries, but you just use it, and the output is a date string, for example, and here the output is a material list or not a material list, depending on the user selection. So quite a nice abstraction, loosely coupled, everything fine. And then time marched on, and we got new requirements. So one requirement was that when a message with this material list was sent, the material list must be conserved in the state that it was sent off. So prices had to be frozen in time, and the list shouldn't be editable by experts from this time on, to ensure that you can look up later what was conversed there with the customer. And not a complicated thing. So the red thing gets a notification, the message was sent, please conserve your state, red little box. Still high level of decoupling, but we have two-way communication now. Before we only had one direction, but not a big problem. Then next requirement, also documents should be added optionally or instead of material list or both together. And we did the same pattern. So having a document system, blue system, new system, where the expert can upload documents, for example. And same requirement, if a document was sent at one time, it couldn't be altered later on. Here also loosely coupled, but now the errors and integration points get a little bit more, so complexity rises a little. And then we got another requirement that connected the red box with the blue box, because some material lists should also come with pre-populated documents. So maybe you have a prepared chat building instruction manual, and these two started to have to work together on the screen. And yeah, we also managed to do this, but there we reached a point where the complexity got quite high. So not from the data being passed around here, but more from the responsibilities perspective. So when there was an error, so customer says, I didn't get the attachment, or the product list was empty, for example, now it was not clear which of these three teams did something wrong there. So all of these three teams had to come to the table, discuss, try to debug their different systems. And this was quite complicated. And we thought along, the this bothered me. So that we had a solution where we had high decoupling, but yeah, I felt it was not so sturdy as we intended it or wanted it to be. And 2 or 3 weeks ago, in preparation of this talk, I talked to Arthur, a colleague of mine, and he talked to me. He's more of a backend services guy, and he talked to me about distributed transaction and some stuff he's getting into right now. And this opened my eyes, and I remembered this scenario I just told you. So we have, when we do a micro frontend system, when we do distributed systems, we have some kind of architecture design principles. So loosely coupled, you saw it on many of the slides. So we use eventual consistency, we prefer asynchronous communication, and we try to avoid central control for coordination for workflows, for example. And for me, up until this point, these were binary properties. So we try to tick every box every time. And what he introduced me to was a concept of not thinking of these properties as being binary, but thinking of these properties on being sliders on a scale. So it would also be an option to not do eventual consistency, but to do atomic consistency, for example, or switch from asynchronous communication to synchronous communication. That would introduce new problems, new issues, but maybe these issues are not so critical than the other issues we were facing. So we could pull all the sliders to the left. I've called this monolith mode because now you have a distributed systems, but all the properties of a monolith, and I think no one wants to go there, because then I think you're in hell when you're building things like this. So tightly coupled distributed system, but you don't have to go all the way. So it would also be fine to do eventual consistency, asynchronous communication, but for one part of the system, maybe the form we just saw, except a little bit of orchestration. So having an outside component that manages how data flows between different things and acts like a transaction boundary or so on. And I think this is quite interesting to reason about this. And my colleague didn't come up with it. It's a concept that Neil Ford introduced. He's written with other people together a great book about this kind of trade-off making, but also other stuff. And there's a 1-hour YouTube video I've linked here where he talks about this topic, and when you pull which slider, which other issues you get into, because it's not about there's a perfect solution, just use it, but it's all about making the right trade-offs for the right use case. And I think getting into this trade-off mindset is very valuable, especially if you think about building micro frontends and not only for doing microservices. Okay, but this is the solution for we change our coupling, decoupling rules, but there would also be quite another way of dealing with the complexity we experience with this form. So questioning are the system boundaries you see there, so the green outline, the red and the blue one, this is not God-given, so someone thought about doing it this way. And maybe we also should question these. And also from a user flow perspective, is this the best way to send documents to the user, or may it also be an option to organize this form in a different way, where these issues we encountered may just not come up in the first place, and makes things easier that way. And this is where I come to my next topic, is think about how we do UX, so user experience, in a micro frontend architecture. So who designs the user workflow, especially when it goes across multiple verticals, across multiple teams, and where's the place to discuss maybe trade-offs? So changing the user interface in one way, which might make implementation or integration much more easier, but might require one extra click, or maybe you find another solution in there. At least in our projects, we have discussions like this, but I think we haven't reached the best workflow in how these discussions and where these discussions are held. So I've tried to paint 3 scenarios how we dealt with user experience in this specific project. So the most classical one, I'm very glad that this one is not rising, so it's on the way out, I guess, is having a UX design department which designs screens for the complete application, gets sign-off from above, from their bosses, whatever, and then goes to the implementation teams and says, okay, now you have to build it like this, and don't talk to me about system boundaries. You figure out how best to deal with it. So if you have this model, I think it's predetermined that you run into quite complex front-end integrations, because during the design process, UX process, the system boundaries are oftentimes not even present in their head. The middle solution is having UX more of UX as a service. So having a UX department where you can go to as team or as two teams, for example, if you have a spanning workflow across multiple teams, and collaborate with them. So seeing the UX people more as partners that you can pull in for help for trade-off discussions, for example. And in a way, an idea I'm quite fond of, but in practice it's quite challenging to do this is to also include UX in the front end, in the complete microservices team, Micro Frontends team. Sorry. So there we're talking about extra height. So adding one more skill to the cross-functional team. So also having UX capabilities. This works great if you're starting a new project and there's UX demand in all of the teams, and it's quite similar. But as we noticed over time, the need for UX work varies quite a lot. So you have some phases where you need a lot of input and a lot of discussions, but you also have months or weeks where there's nothing to do for someone whose main job is doing UX considerations and testing and so on. So we don't have a perfect solution, but I really urge you to think about how user experience, how your user flows are designed, and how to get this in sync, aligned with your system boundaries, because I'm convinced that this will make your application, or has the potential to make your applications far less complex, especially at the integration points. And also discuss trade-offs in quite an early stage, and not in stage where all screens are ready and then you come in from a technical perspective and say, maybe change these patterns, so on. Okay, so now my last slide. I'm quite good at it with the time. That's good. Is now we get to the fifth column I teased earlier. We have two bigger clients where we not only did this verticalization on a technical level, so the green boxes, that's having these verticalized tech systems with cross-functional teams, but these customers also reorganized their business unit to align with these domains. So they have business units that a unit that handles the checkout, for example, or a unit that cares about how product search is done in their system. And so you have business alignment with your technical team. So if someone in business says, okay, we have a new idea, we want to test out the following hypothesis, it is very, very easy for them to, because it's quite clear that they can discuss it with their own team, because the business to system relation is quite clear there. And it can be prioritized, it can be validated and implemented quickly, because it all happens inside of these boundaries. So you can iterate quickly, and you have a quite fast time to market. And this is the reason why at least these two bigger customers also adopted this verticalization pattern also for their business units. And now to complete the slide, all of the properties we saw from the full stack team, so the fourth column, also apply when you add business, so you don't gain something in regards to continuous delivery, I guess, when you also include business, because it's mostly technical properties. But the time to market, so the time it takes from an idea to getting it on the street and trying it out and validating it, this is the huge boost you get when also business is aligned with your technical systems. Okay, so yeah, I've written a book. We also heard it before. You can get it at a discount. Yeah, and thank you for listening. If you like the cover image, I like the cover image very, very much. It is drawn by a coworker of mine, Fabricius, who's also a Micro Frontends expert. And he has not only drawn this image, but a lot of images that are these square style. Maybe you should check out his Instagram profile or his website and look at his images. I find them quite inspiring and quite intriguing. So if you want to get the slides, you can get them on my personal website. You can find me on social networks everywhere under the name Naltatis. And thank you for listening. And since we are good in time, maybe I will just before we do the Q&A, I have a poll, a small music quiz and Micro Frontends question prepared, which I will go into. So if the title of this talk is "How Deep Is Your Micro Frontend?" And it's a riff on the song "How Deep Is Your Love." And in the preparation of this talk, or since I've published the title of the talk, different people talked to me and had associations. The association are, oh, okay, this is about the song or has something to do with the song. But what I found quite interesting is that these different people didn't always mean the same song. So I did a little bit of Googling and found out that there are at least 3 very popular versions of the song that were in the charts at one time. So the original is from the Bee Gees in 1977, and then exactly 19 years later, Take That did a cover of the song. I guess this is the thing that plays in my head when I hear the term "How Deep Is Your Love?" And then exactly 19 years later, Calvin Harris also made a song. I guess it's not a cover, but it also has this prominent line in this. And this is a thing my daughter, my 14-year-old daughter, had an association with. She didn't know the other songs, but she thought what I was talking about or associating with this Calvin Harris song. And I would invite you to scan this QR code or go to menti.com, and maybe we can also post this link in the chat to the poll. And then I would like to hear from you which song you associate with the term "How Deep Is Your Love?" And when you've finished this one, there will be a Micro Frontends question afterwards. And on the last slide, you can, if you want to, enter your email address, and I will give away 3 free ebook copies of my book. I will use the emails only for this giving away of books and delete everything afterwards. And yeah, so okay, I see 14 people have already voted. Okay, I will leave this voting open. And yeah, the next question is, how deep is your Micro Frontend? So title of the talk, and there you can pick multiple dimensions, so tick multiple answers, and I would really be interested to see how deep your Micro Frontends are, so what disciplines you are able to integrate into your teams. And I'm quite surprised and very delighted to see the yellow bar not being flat at the bottom, but also having 4 entries there. So okay, I will leave it at this. The results of this poll I will add it to the slides you can find online, so you can see the results there as well. And again, thank you for listening. And now we can do the Q&A.
Thank you, Michael, for the amazing talk. I find it really interesting to see how the paradigm of a technology, in this case Micro Frontends, even influences the process of software development, right? So in this case, we use the technology and change the scope of development, and so we modify the underlying processes of the teams developing the feature. And I'm not the only one finding your talk very interesting, because we have a lot of questions from the audience. So let's dive into them.
Okay.
So our first question is from Robson. He's asking you, what is your experience regarding those high-depth full-stack teams? I see often back-end focused teams with only basic front-end knowledge, so they have a staffing problem.
Yes. This is, I guess, having the division between front-end and back-end. So we have a technical barrier there. So in many cases, we have front-end frameworks and back-end frameworks. So very few people feel comfortable to be active in both worlds. So we have this barrier there. We try to work against this. So having at least people who enjoy one of the two things in our team, so that we don't have just a team of backend guys who also have to do front end against their will. So this oftentimes doesn't work very well, but it's definitely challenging, especially because the industry. So people call themselves front-end developers and back-end developers, and we encourage this because this specialization is something that people also enjoy. So in my introduction, I also said I'm not quite sure what did I say. I said I was a front-end developer, a software developer, but I'm quite not sure. We try to don't open these boxes and talk about people more as software engineers and not about being a specific skill.
Exactly, like in a good full stack team, everybody should know a little bit about everything,
Yeah.
right? You don't have to, you still can keep your specialization, but it's always good to like widen up your horizon a little bit, right?
Yeah,
Okay.
I guess in our job postings, we do job postings for backend developers and also for frontend developers. But in both postings, we say that we would enjoy this. The person is not afraid of working in the frontend or is not afraid of working in the backend. So to try not to encourage this group building that the technology encourages by itself already.
Oh, okay, awesome. The next question is from Emil. He is asking you, do you have any suggestions for how to mitigate the drawbacks of high depth? And do you have any tips and tricks for convincing the business to switch from front end only depth to the full depth?
Two questions. So this is the
can go one by
drawbacks
one.
of high depth. So there were different stuff. So one was a cultural thing. I guess the question before also addressed this a little. So encouraging people to not stay in their front end or back end or whatever tech domain, but being able to collaborate. Yeah, it's not a technical problem. It's in many cases a cultural problem for people to want to work together. And from a business perspective, so convincing business that it's a good idea to go deeper. I guess the time to market and the concept of being able to ship something faster. So the slides I showed before, they are not technical slides. So this should be arguments that someone who wants to be productive or run a productive team should be able to understand and should be able to be convinced about. But these are also discussions in our project where it needs at least one or two person on our customer side that are convinced that this is the right way to go, and they evangelize, because you have to convince a lot of people if you want to do a reorganization of existing departments. You're taking away a lot of stuff and creating fear. So this is not easy to do this.
What's sticking in my mind was your slide with the sliders, no pun intended, right? To make sure that the people stop thinking about only binary terms like black and white, to make always clear that it's always a trade-off, right? You don't have like drawbacks. In most cases, you trade one benefit for the other or vice versa.
Yeah, doing an informed trade-off, and the informed is important. So you can also use it as it doesn't matter, everything goes. Then you get into a messy situation very fast. But having the vocabulary and having these fine-grained discussions, if do we accept this trade-off or do we accept this trade-off? I think this is a skill it's worth training. Yeah.
Okay, thank you very much. Then a question that goes with this topic very good is this one. So would you agree that having many verticals and independent teams make it very important to have people just working on the design system? Otherwise, I see a lot of shared but distributed ownership.
So I would agree that having a shared design system is crucial. So at least for the projects we do, we always have a shared design system. And in the past, we had both solutions. So having a dedicated team who only do the design system. But the way I enjoy a little bit more is to have maybe a shared responsibility in the sense of there are people from different teams. It doesn't have to be all of the teams that are as a group responsible. So more of a collaborative open source project between the different verticals with clear maintainership and ownership. So someone has to make a final decision, for example, so that we don't stuck in discussion. But I always have the urge to not create unnecessary teams that are not aligned with the verticals, to avoid having these teams develop interests of their own. So the design system team wanting to adopt a new technology just to adopt a new technology without feeling the need from the product teams, for example. But I guess both is possible, but I'm leaning more to this having the distributed and more open sourcey character.
Okay, awesome. Now we have this like a very similar question, but from the perspective of a developer. So how do you manage the code ownership and then the high vertical teams?
This is quite easy. So we had this green boxes, and in practice, a green box is most often one source code repository, or maybe a group of source code repositories when the team decides to do microservices and so on. And the team that has ownership for the green box also has the complete ownership for the code. And you have some kind of shared ownership, as we talked in the question before, like the design system, but it's also important to assign clear ownership. So someone has to do final word in the discussion, for example. Mm-hmm. So and we also do we have a transparent setup, I think, which is quite common. So the teams are able to look into the source code repositories of all the others to maybe get inspired, for example, by other code, but the team only modifies and deploys their own code.
Mm-hmm. Thank you very much. So we have time for one more question, and we have a very interesting one. So what is the biggest unsolved problem in regards of micro frontends, in your opinion?
Okay.
A heavy hitter
for my glass bowl. I'm not quite sure. So I guess over the last year since I started working on Micro Frontends, a lot of solutions have come in place. So module federation, for example, fixed a huge thing where that for people that got to know this the Micro Frontends architecture, and their first argument was always, it's bloaty and you're loading everything multiple times, so on. And I think we have a solution for this one, and a really good solution for this one. And the hard topics are more to the questions we had before. So how to deal with convincing organizations, how to keep this setup sane, how to keep engagement. So I don't see pressing technical issues, at least in the projects I'm working on, but see more of running such a system and having the cultural work. I think this is quite challenging to keep this up.